Hi everyone, I'm Cheryl. In this problem, we're given a function, f of xy equals 16 minus x squared minus y squared, and we're asked to evaluate that function at the point 2, 1, at the point 2.1, 1.05, and then find the change in z. Once we do that, we're going to use my total differential to approximate this change in z. All right, so let's begin, first of all, by finding f of 2, 1. So I'm going to have 16 minus 2 squared minus 1 squared. So in other words, I've got 16 minus 4 minus 1, which is 11. Okay. The next part asks me to evaluate the function at 2.1 and 1.05. So this is going to be 16 minus 2.1 squared minus 1.05 squared. All right, I think I'm going to use my calculator to help me with this one. So I've got 16 minus 2.1 squared minus 1.05 squared, and that's going to give me 10.4875. Okay, the next part, we want to find the change in z. So the change in z is what happens when I take f of 2.1, 1.05 and subtract f of 2, 1. Now I've already done these calculations. This is going to be 10.4875, and then I'll be subtracting 11. And when I do that, I'm going to get a minus 0.5125 if I plug that in. All right, now that was a lot of number crunching. I want to see if I can use the total differential to approximate that value. So let's go ahead and find the total differential. I know I can find the total differential by taking the partial of z with respect to x times dx plus the partial with respect to y times dy. So for my particular problem, if I take the derivative of z with respect to x, remember I'm treating y as a constant, my derivative is going to be a minus 2x. So I have minus 2x times dx. And now I take the partial with respect to y. So I'm going to treat x as if it's a constant, and my derivative will be minus 2y. And again, I'm multiplying by dy. Well, what is xy, dx, and dy in this particular problem? Well, I know that my x is going to be 2. So let's say x equals 2, and y is going to equal 1. Dx is going to be the change in x. So when I move from 2 to 2.1, dx is going to be 0.1. When I move from 1 to 1.05, dy is 0.05. So let's plug that in. I'm going to have minus 2 times 2 times dx, which is 0.1. Then I'll be subtracting 2 times y, which is 1, times dy, which is 0.05. If I number crunch this, I'm going to have a negative 0.4 and a minus 0.1, and I get a negative 0.5. And I can see that these two numbers are very close to each other. So I can use my total differential as an approximation for the change in z. I hope that was helpful. Thanks.